Hi guys, I'm gonna teach you about mathematical induction and celebrity problem and knapsack problem. So let's start for mathematical induction. I hope you understand what I'm explaining here. I'm a little bit nervous, so let's start. What is mathematical induction? Mathematical induction is a mathematical proof technique. It is essentially used to prove that a statement P and hold for every natural number. For example, 0, 1, 2, 3 that you can see now in your screen, and 4 and so forth. So they say that mathematical induction is like a falling dominoes or climbing ladder. Next. So a proof induction consists of two cases. So there's a two proof by induction. So the first one is base case or basis. Basis prove the statement for n equals 0 without assuming any knowledge of other cases. So the second case, the induction step, proves that if the statement holds for any given case n equals k, then it must also hold for the next k and k plus 1. Those two steps establish that the statement holds for every natural number, and 3. The base case does not necessarily begin with n0. So in the base case, we base case base case does not necessarily begin with 0 but often with n equals 1 and possibly with any fixed natural number n equals n, establishing the truth for the statement for all natural number n greater than n. So next, next okay, so let's go to the base step by step. Step 1, it proves statement is true for initial value. Step 2 is proved if the statement is true for the nth iteration or number, and then it is also true for n plus 1 iteration or number n plus 1. So how can we do it? Just step 1. So in the step 1, consider an initial value which the statement is true. It's to be shown that the statement is true or an initial value. So the problem number 1 is 3 and negative 1 is multiple of 2 for n equals 1 and 2. So solution, I'll give you solution. So step 1, for n 131 equals 1 equals 3 negative 1 equals 2, which is multiple of 2. So okay, so step 2, assume the statement is true for any value of n equals k, then prove the statement is true for n equals k plus 1. We actually break n equals k plus 1 into two parts. Of one part is n equals k, which already proved, and try to prove the other part. So let's assume that 3 and negative 1 is true for n equals k. Hence 3k negative 1 is true. It is an assumption. Ay, sorry. So let's start. So we it is we have to prove that 3k plus negative 1 is also a multiple of 2. 3k plus 1 negative 1 equals 3 times 3k, negative 1 equals 2 times 3k plus 3k equals 1. The first part, 2 times 3k, is certain to be a multiple of 2, and the second part, 3k negative 1, is also true as our previous assumption. Okay? True as our previous. Hence, 3k plus 1 is a multiple of 2. So, we prove that 3 negative 1 is multiple of 2. So, sorry sa pag-edit ko kasi hindi ko nalagay ang true as assumption. Sa next part, problem 2 tayo. Okay. Problem 2. 1 plus 3 plus 5 equals 2n plus 1 equals n2 for n equals 1, 2. So, start step. For n equals 1 plus 1 equals 1, 2, yung step is satisfied. So, yung sa step is satisfied na siya. So, step 2 is let us assume the statement is true for n equals k. So, like I said kanina, ang step 2 is always assume that statement is true, but we need to prove it is true. So, hence, 1 plus 3 plus 2k equals 1 equals k2. It is true, so it is an assumption. 1 plus 3 plus 5 plus 2k plus 1 negative 1 also holds. So, this is the holds. 1 plus 3 plus 5 plus 2k plus 1 equals 1. 1 plus 3 plus 5 plus 2k plus 2 equals 1. 1 plus 3 plus 5 plus 2k plus 1. 1 plus 3 plus 5 plus 2k equals 1. Plus 2k plus 1 equals k2 plus 2k plus 1 equals k plus 1, 2. So, 1 plus 3 plus 5 equals 2k plus 1 negative 1 equals k plus 2 holds, which satisfies the step 2. Hence, 1 plus 3 plus 2n equals 1 equals n2 is proved. So, na-prove natin ang sa problem 2. So, let's go to the celebrity problem. So, what is celebrity problem? So, it is like a party, okay? In a party of n people, only one person is known to everyone. Such a person may be present party if yes, she doesn't know anyone party. We can only ask question like, does A know B? So, it's like we have a having parties, so like us people, or like, oh, do you know, like that, like this. So find the stranger celebrity in the minimum number of questions. So here in the celebrity problem, we can describe the problem input as array of number characters representing person in the party. We can also have hypothetical function have acquaintance A and B. A hypothetical function have acquaintance A and B which returns true. If A knows B, so if nakilala niya, if si A ay kilala niyang B is false, otherwise, how can we solve the problem sa kana which is? We have a three method. First, graph. What is graph? We can model solution using graph initialize degree and out degree of every vertex of series. So, the graph is if A knows B, draw the edge from A to B. Increase in degree of B at degree of A by 1. Construct all possible edges of the graph for every possible pair. We have NC2 pairs. If 70% of the party, we will have one sync node in the graph without degree of 0, and in degree of n negative 1, we can find the sync node in n time. But overall complexity is 0 and 2 as we need to construct the graph first. So let's go to the method 2, recursion. We can decompose problem into combination of smaller instance. Say if we know celebrity of n, one person, can we extend to the solution of n solution to n n? So the answer is we have two possible celebrity n, one may know n or n already knew celebrity n negative 1. In the former case, n was celebrity if n doesn't know anyone else. In the later the case, we need to check that celebrity n negative 1 doesn't know n. So we need to check if the celebrity n1 doesn't know n1. So solve problem of smaller instance during divide step. On the way back, we find celebrity if the present from the smaller instance. During combined stage, check whether the return celebrity is known to everyone and doesn't know anyone. The recurrence of the recursive decomposition is ito na yung example. So this is the example. Tn equals tn negative 1 plus 0 and tn equals 0 and 2. You may this is the sample recursion. So method 3. What is using stock? The graph construction takes on 0 and 2 time. It's similar to tribute for search in case of recursion. So using stock is we reduce the problem instant by not more than 1, and also combined step may examine n negative 1% m is instance size. We have following observation based elimination technique. So here's a technique. Push and sorry. So this, if A knows B, then A can be celebrity. So kung makilala sa ni B, kung kilala ni A ang B, so hindi sila magka-celebrity. I-disregard ang A and B may be celebrity. And ang B ang may be celebrity. If A doesn't know B, then B can celebrity. So kung ang A ay hindi niya kilala ang B, then ang B can hindi ba maging celebrity. Disregard ang B and ang A ang maybe celebrity. So i-repeat lang. Let us just repeat that two step. It will left with only one person. Yes, it is only one person. So ensure reminded person is celebrity. Why do we need this step? So bakit natin kailangan ng step? So we need this step because we can use stock to verify celebrity. So 1, push all the celebrity into the stock. 2, pop of top 2 person from the stock, discard 1 person based on return status of health acquaintance A and B. 3, push the remaining person onto stock. 4, repeat step 2 and 3 until only 1 person remains stock. And 5, check remain person in the stock doesn't have acquaintance with anyone else. So, 1, i-push mo ng celebrities into the stock. So two puff of top 2% from the stock discard. So puff of top 2% from the stock discard 1% based on return status of have acquaintance it. So push the remain of person into stock. So itulak mo ang natitirang stock. So 4 repeat mo na lang just that just repeat step 2 entry until 1% remains stock. So repeat mo ang step 2 entry hanggang sa isa na lang matitira sa stock. So i-check mo ang remain person in stock doesn't have acquaintance with anyone. So i-check mo ang natitirang person in stock kung wala siyang ang acquaintance wala siyang kasama or kasal mga na iba. So we will disregard n elements outmost. So why? If the celebrity is present in the party, we will call have acquaintance 3 and negative 1 times. So that's next thing. So knapsacks the last. So ano what is knapsack problem? Totally, the knapsack problem is a problem in the conventional optimism given set of items, each with weight and value. Determine the number of each item to include in all collections so that the total weight is less than or equal to given limit and total value is large as possible. So, given is a sub-item each weight and value determines a set of items include. So, knapsacks is a combination optimization problem. It's a pure sub-problem in many more complex mathematical models of real-world problems. One general approach to difficult problem is to identify the most restrictive constraint, ignore the others, solve a knapsack problem, and somehow adjust the solution satisfy the ignored constraint. So let's next. Applications. In many cases, resource allocation along with some constraint. The problem can be derived in a similar way of knapsack problem following it as set example. Finding least wasteful way to cut raw materials. Portfolio optimization, cutting stock problem. The next, fractional knapsack. In this case, items can be broken into smaller pieces and the thief can select fractions of items. So there are So there are n items that store weight of item greater than 0, profit for item pi greater than 0, and capacity of the knapsack is W. So knapsack is in this version of knapsack problem, item can be broken into small pieces. So the thief may take only fraction xi of items. So the problem here, example. A thief robbery a store and can carry a maximal weight of W into his knapsack. There are items available in the store. Weight of item is WI and is of profit. It is PI. So what item should that thief take? So, in the context, the item should be selected in such a way that thief will carry those items, for which he will gain maximum profit. Hence, the objective of the thief is to maximize the profit. So, here, 0 0 xi is 0 great less than xi less than 1. So that the the 8 contributes weight xiwi to the total weight in the knapsack and profit xipi to the profit. So hence objective of this algorithm is to maximize n equals 1 xipi subject constraint and xi n n equals 1 xi wi is greater than w. So next, it is clear that optimal solution must fill the knapsack exactly. Others we could add a fraction of one of the remaining item and increase overall profit. Thus, optimal solution can be obtained by n equals 1 x I equals w. So that's all. I hope you understand what I'm explaining. So thank you so much. Goodbye. So my name is Shaira I Abubakar, third year college. So thank you very much.